We'll proceed in vector and commercial calculus. Vector and commercial calculus, very precious and very different. Okay, so in vector and commercial calculus, we are in a war, in a battle kind of situation where we are thinking that my energy force field, okay, if I have a vector field, it is path independent or not. So that is the discussion that we are pursuing for past 4 5 days. That my force field is path independent or it is independent. Okay, many examples we have given. Okay, so Earth is a big mass and it has gravitational pull. This is what people generally they study in the physics. Okay, Earth is a very big mass, and since it is a very big mass, it has attraction. It attracts anyone. Okay, this is kind of Newton model. There is energy model also. Earth is a energy source. Earth is an energy source, and it since it is an energy source, it has energy. Okay, why it has energy? Can someone prove it that Earth has energy? Okay, I can try proving it. Earth has energy. Oh, see, okay. This is not the Earth has energy. Earth is a big mass. Any mass attracts other mass as per the Newton's law and this law and that law. Okay, I am not saying any bad word to Sir Newton, but this is what it is. Any mass try to attract other mass. If mass is very big and other mass is small, it tries to attract it. Okay, this for the Newton's formula. Since sun is very big, its mass is very sun is very heavier to earth. Sun is far bigger and far heavier to earth, even though it is a gas planet. Sorry, gas star. A star is gas only. Even though it is a gas celestial body, but the mass of the sun is very high. And then since mass is very high, it attracts earth. Earth mass is very high, it attracts satellite, that is moon. Okay, moon mass is very high, that's why if someone goes near moon, moon will attract it. Mars, Mars, Mars mass is very high, that's why it attracts Phobos and Deimos. To not get attracted toward Mars, they rotate around the Mars. Okay, so that is the concept that is gravitational gravitational pull and this and that. So many things are there in this concept. There is another concept called energy model. Energy model. There is nothing free. There is nothing free. Energy is not free. Energy changes its form. If I have one entity here and it moves automatically here, from here to here, means there is energy involved. That's why this move from here to here. Someone lost the energy. Like example I give, I had okay, okay, and and what is else? I don't know this. These are real brass or they are iron only. I have a magnet. Okay, many times I have showed it also. I have magnet. Wow, I have locks, and they are really not iron. I was thinking they are cheap. That's why they are iron. They are not iron. Okay, no problem. Okay, many times I have showed this. This is a magnet. This is a magnet, and this is iron. Okay. Now, if I am feeling the force. Okay. Now, if I leave this, Okay, it is going, even though Earth is pulling like this, but it is going toward the magnet. Okay, anyway, it's common thing, right? Now, if it is moving against the Earth and going toward this, then someone is working, right? I'm not working. If I am doing like this from here, 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 I'm losing energy because item is moving like this. Then this movement needs energy. Okay, this movement, if item is moving from here, here to here, with velocity v, mv square is the energy is required. Okay, now I'm moving from my body energy, moving from body energy, and then suddenly it attracts from from here, from here, from here to here. Okay, that much distance. If it move because of this magnet. Okay, I'll take dual magnet. I believe the traction will be even higher. Okay. Now, if that is the case, then if it is moving, probably this is 3 centimeter it moved. If 3 centimeter mass is moving, then moving from which energy? The magnet energy. If I keep keep doing like this, okay, keep doing like then this will be demagnetized. Energy is stored in this. This is behaving like an energy source. If it is an energy source, it has a force field. Energy has a force field. Earth has a force field. In that force field, this item is coming. And then again, and with the force field, Earth started working. Is it not working? Earth is working. Earth is losing energy. If you keep dropping item, then Earth is keep losing the energy. Okay, if keep living like this and it is sticking like this, okay, then this magnet is demagnetized every time because that much energy, 3 centimeter it is pulling. 3 centimeter, if item is moving, then that much energy this magnet is losing in one go. Keep doing it, one time will come when it will be completely demagnetized, completely, because that much energy what you see, how much is the energy spent, how much is the energy is required to move 3 centimeter of this much mass. Okay, mass into whatever the acceleration is, this into the distance, mgh, mass whatever the acceleration, the magnetic force. If I know the magnetic force, then force into mass, force into, okay, force by I'm sorry, if I know the acceleration, the acceleration of the gravity, the gravitational pull of this magnet, then if I multiply it by the mass of this, then it will be force into displacement. That is the energy spent. Okay, that energy, if that is 10 joule, 10 joule of energy is gone from this magnet every time. Okay, it is good. So this is energy science we are talking about. In energy science, we know that there are two terms. One is called path dependent and one is path independent. Path dependent, if item is moving from one location to other location, then energy spent from, if if this magnet is energy source, this magnet is energy source. Because of this energy source, this is moving from here to here. Okay, now because of this, consider moving from here to here, how much energy this magnet lost. Now instead of moving in a straight line, now I am piercing this. I made a hole here. Inside this I made a hole and put it inside like this. Now same distance. Now if I plate magnet, magnet will start attracting it, but it will go through this path only because it is inside this. Then how much energy magnet lost when begin point and end point is same? Here also it is moving from here to here only. Here it is moving in a circular path, whatever path. If energy lost by this magnet only depend upon the begin point and end point, not on the path, then this magnet is called path independent. Otherwise, magnet is called path dependent. If it is path dependent, then if you take longer path, the energy consumption from this magnet is more. If you take short path, then energy consumption from this magnet is less. Okay, so energy consumption on the magnet is dependent upon the magnetic force, that is constant. Mass is constant. magnetic force is constant and then multiplied by distance. So if magnetic force is constant, the energy consumption is directly proportional to the distance we are taking. If it is path dependent, shorter distance, less energy consumption from this magnet. Longer path, more energy consumption. Okay, now I want to know the nature of this magnet, how much it is path dependent. In that sense, if I calculate the energy consumption, then it is dependent upon the path. I want nature of this, not the, if I take bigger path, the energy consumption will be more. From the from the, what is the factor through which I can say how much it is path dependent. If it is very little path dependent, consider it is very little path dependent. If it is very little path dependent, if I change the direction of the displacement, it won't change much. But if it is higher path dependent, then net energy calculation will be proportional to the path distance, path length. How much it is path independent? Then one way of calculating this is take a circular loop. Take a circular loop. And circular loop item is moving in this magnetic force from here and coming back to the, take a closed loop. Item is moving from here and coming back to here. Net energy calculation should be zero if it is path dependent. The begin point and end point is same. If it is path dependent, then it will be dependent upon the path, how much energy is consumption from is the consumption from this energy source. Begin point and then end point should be same, then it will depend upon the path, the energy consumption we are talking. Okay, in that sense, that is the energy consumption. Okay, now, but that is not constant. If I take circular path of radius a, then energy consumption is more in a circular route. If I take radius of a by 2, then energy consumption will be less. Okay, no, I want something that is constant. That is the nature of this energy source. Something that is constant. It is not constant. Energy consumption in a closed loop is not constant. Depends upon the path. What is constant? If path is bigger, then divide it by the area. Area is also bigger. Then looks like it is constant now. If I take a small circle and rotate from this point and back to this point, then path is small. Then energy calculation is small because force into displacement is small. Divide by the area, divide by the area, then this is called circulation density. That is the net path dependency calculation of an energy source. Take a closed loop and move an item from one point and coming back to the same point. See how much energy is consumption has been made. Divide it by the area of the closed loop. Now we are neutralizing, normalizing the distance fundamental. Then it will come, energy calculation will come in the characteristics of force only. The energy is force into displacement. If I divide it by the area, then displacement factor we are normalizing. Net energy calculation will come in the term of force only. Okay, so this is called circulation density. Energy in a closed loop, that if in this force field of this magnet, if item is moving in a closed loop, calculate how much energy it lost, divide it by the area, that is called circulation density, and that is something that gives the path dependency characteristic of this magnet. Okay, another fundamental is if this path we are talking a circular, it is consider it taking a circular path against this magnetic field, this item is moving in a circular path. It is starting from here, coming back to here. Now this path is changing its direction. Okay, area is same, but it is changing its direction. If it is changing its direction, we are talking in vector term. Force is constant. If magnet is kept static somewhere, then magnetic force will be radial to it. Okay, it will be radial to it. And then if the direction path, if I see this, if I see, if this is x-axis, this is y-axis, this is z-axis, then right now the path is in xz plane, path is in yz plane, path is in xy plane, path is in xyz plane. Okay, in that case, depending upon the path direction, the net energy calculation will change in force vector field. Consider force vector field is like this. Okay, and my path is like this. Then path vector will be, this is force field and path vector field. Path is like this. Force path vector will be like this. Force vector is like this. Now they will make different angle. And net energy calculation is force vector dot displacement vector or force vector dot d of position vector, whatever it is. There is dot product there. Dot product talks about the angle between the force field and the displacement field. So displacement field, every moment displacement field is tangent, displacement vector along a circular path is tangent at that point. That is changing. It is algebraic function. So in that sense, that this then if I keep changing its direction, the displacement vector direction is changing. Force vector dot displacement vector net energy calculation is different. If that is the case, then in what direction if I take then force vector dot displacement vector, then energy calculation is maximum. Calculate the maximum energy that will be that will be consumption that will be consumed from this energy source magnet when atom moves in a closed loop. Change the direction and force field is same because it is static. But if you change the direction, it will keep changing. In one time will come when energy computation is maximum. Divide it by the area of the circle. Then at that moment, the circulation density, that is the energy calculation is closed loop divided by the area, will be maximum. What is the direction of the circulation? In which direction you are calculating the circulation density? Someone would ask. Take a direction in which it is maximum. If it is in this direction, okay, then if this is the surface, then from the surface take the perpendicular direction, exactly perpendicular direction. If it is xy plane, then it will be z axis. That is the direction in which the circulation density is computed. If it is xz plane, then y direction. If it is yz plane, then x direction. If it is some any arbitrary plane, the perpendicular to the surface, you take the direction. That is the direction of the circulation density. It is also called circulation n. N is the direction of the surface along which the circulation density was calculated. Circulation n is equal to the energy computation in the closed loop in that direction divided by the area. Okay, now let's calculate. This is same as if I go by the gradient vector. Same as if I go by the curl vector. Curl vector is if it is three dimension. If it is three dimension and force is a three dimension, that is force vector F equal to F1I plus F2J plus F3K. Then it is then it has three. The force field is in it has three components, one along I axis, one along J axis, and one along K axis. Okay, that is F1I plus F2J plus F3K. Similar fashion, the curl what we calculate, it will also have three components, I, J, and K. I will be df2 d sorry d df2 by dz minus df3 by dy minus df2 by df3 by dy minus df2 by dz, that is in I direction. Then d df3 by dx minus df1 by dz in j direction, df2 by dx minus df1 by dy in k direction. Someone calculate the curl vector. Take a matrix, first row is I, J, K, next row is gradient vector, d by dx, d by dy, d by dz. Third row is the force vector, F1, F2, F3. Now calculate the three determinant, and that is the curl vector. Curl is, many times I have said, one way to calculate how much it is path dependent, energy is how much path dependent is calculating the circulation density. Other measurement is calculate the curl, how much torque it is generating. Torque means if this is magnetic field, if this is magnetic field, this is magnetic field, and this is the path of the movement of a particle in this magnetic field. Because of this magnetic field, how much torque is seen. Okay, consider this is the path of the iron that is moving. This is the path of the iron that is moving in a straight line. If it is moving in a straight line and if it is moving, if path is moving in a straight line and this is the force field from the magnet, then how much torque it is generating? Okay, if force field is here, this is force field has two components. If we are talking about 2D, one is F1 component that is along x-axis, and one is F2 component that is along y-axis. Now through F1, it will try to push this particle. The particle is moving, or if particle is moving in a circular fashion. If particle is moving in a circular fashion, then if this is the force because of the magnet, this force has x component F1 and it has y component as F2. This is x axis, this is y axis, this is minus x, whatever. This has F1 component and F2 component. If this item is moving because of this force, then on this item, F1 component of the magnetic field will try to push it away. F2 component will try to push it away in this direction. All right, no problem. But problem starts happening when F1 is changing if I go along y-axis. There is y component in F1. So dF1 by dy is not 0. Similarly, F2 is changing if I go along x-axis. F1 and F2 can be algebra. Okay, like F2 is x square, F2 is x into y. Then there is x there. This proves that F2 will change if I go along x-axis. Df2 by dx is there. In that sense, on this item, what we are saying, if F2 is changing, along x-axis, it will consider this item is this. This is the iron, and it is moving in a circle. This is the iron. This is the iron, and it is moving in a circle. Consider this is the iron, or this is the iron that is moving in a circle. If this is the iron, and there is a force field F1. F1 is changing. If I go up, then F1 will make a torque. Otherwise, it will push it. If F1 is here, same as F1 is here, it will push it. Okay. Similarly, if F2 is here and F2 is here, same, it will try to push it. Okay. If that is the it okay. If F1 is here different than F2 is here different than F2 is here, then it will make a torque. If F1 is here different than F1 here, it will make a torque. Net torque, this guy is rotating in a circle. While rotating, it will be constant. But if there is a torque factor that is coming from the force field, that is dF2 by dx minus dF1 by dy, that is the net torque. Okay, if this is the item, then torque by F1 is in this direction. Torque by F2 is in this direction again. Okay, one will make it rotate like this and one will make rotate like this. If they nullify each other, then it will silently move in a exactly like this in a circle. No change. But if they are generating torque, then it will move along its own axis also and then move along the kind of something like Earth is rotating on its own axis and then rotating around the sun. Similar, I don't know, sun gravitational pull is path dependent or independent, or Earth is rotating on its own axis because of some other energy. But it is something like this. So if this item is moving in a circular fashion in a force field from an energy source, and force field has a torque factor, curling factor, that is dF2 by dx minus dF1 by dy is not zero. In that case, this will rotate, but it will rotate like this also. Means it is receiving torque, it is receiving curl. If it is receiving curl from energy source, then this is the energy source is called path dependent. If it is independent, like Earth is path independent, it will not rotate. But if Earth is path independent, Earth in a gravitational pull is part, it will come down and it will rotate also. This is also called measurement of path dependence. How much curling it is making. If energy source is making very high curling, means path dependency is very high. Or circulation density, the energy in a closed loop divided by the closed loop area is very high, then again circulation density, then path dependency is very high. We have proved it is same. df2 by dx minus df1 by dy, that is the curl factor in 2D dimension. It is same as circulation density. If circulation density is not maximum, circulation density we said we calculate the energy in a path and energy changes if we change the direction against a force field. If I have calculated the energy along any direction, this is direction of the path, any direction, not the maximum we are talking, any direction. Then along this direction, what is the circulation density? Whereas df2 by dx minus df1 by dy, or if I take the three dimension, then df3 by dy minus df2 by dzi plus df1 by dz minus df3 by dxj plus df2 by dx minus df1 by dyk. That is the curl vector. Then someone can calculate what is the direction. That is the direction of the maximum energy. But if someone is calculating the circulation density along any direction n, then we have to, if in order to equate it to the curling factor, whatever curl we get, we have to do dot product against that direction. So net circulation density is curling factor, whatever curl factor we get, dot along the direction which we have calculated the circulation density. If they matches the direction, then dot has no meaning because they are in same direction. Makes sense, right? If I rotate this circle and at one point it has a direction like this. If I rotate like this, at one time it has a direction like this. The direction is n. Okay. Now if now I have a force field and I calculate the curling of this force field and net direction is like this. So this is the direction where the circulation density should be maximum. But I calculated circulation density in this direction. Now, if I have a curling factor along this direction, but I want in this direction, then I have to do dot product. Dot product will take essence of this in this direction. Makes sense? So, circulation density along any direction n is same as curling factor dot in that direction. If circulation density is calculated along a vector n, then curl tendency what we calculate dot n vector, dot n unit vector. That is the net equation. But if I see the maximum circulation density, then curl vector and this vector will be same. The dot product has no meaning. Anyway, now one exercise we will do and then we will do more exercises. Now one exercise is that if there is a force field, if there is a force field and that is along the circle, force field is a algebraic vector. Force field is not a constant direction. Force field is algebraic vector and it is along a circle. Okay, this is r vector. It is centered at the origin and this is radius vector. Force field is everywhere perpendicular to the radius vector along the direction of the curve only. And one particle is moving in a closed loop in a circle, coming from here and coming back to same location, starting from here and coming back to the same location under the force field which is exactly in the direction of the path. The magnitude of force is 2 into the radius. If radius is r, the force power is 2r. Now calculate the circulation density. Okay, circulation density means what is the energy involved moving an item from here back to here divided by the area. Okay, now force field and direction field are in same direction. Same direction. So force dot displacement is the net energy, or force dot d of position vector is the net energy. Force is 2r. 2r into r direction. 2r is the radius. R is a fixed radius. Consider it is a fixed radius r. Then double of the r. Famous example. Double of the r. Double of the r in the r vector. R vector in the sense or 2r vector. That is better word. Now magnitude is r only and direction is r direction. And displacement vector is also in r direction. In that sense, I can directly say force into displacement will be the net energy calculation. So force is 2r and displacement here it is 2 pi r. Then it becomes 4 pi r square divided by the area pi r square 4. Okay, 2 and 2 pi r 4. pi r. Pi r square 4. 4 is the circulation density. Okay, this means that the energy source through which the force field, the force vector field is energy source is like a amazing, right? Energy source generally it will be radial. If this is magnetic field, the force field will be radial like this. If there is a earth, then force field will be radial. If this is the cross section of the earth, then force field will be, or earth will be like towards the radius. Everywhere it is attracting towards its center. Similarly for the magnet. But there is some energy source for which force field is along the curve. Force field is along the curve. If that is the case, then path dependency strength of this energy field is 4. Constant 4. Amazing, right? Okay. 4 pi 4. Constant 4. Now, someone can consider as a assignment. I think we had given other assignment also, proving that Earth gravitational pull is path independent. So next session we will take in the example one. Now we know that circulation density is nothing but calculating the kind of energy in a closed loop divided by the area. Okay, whatever direction I have taken, that is the direction of the circulation density. Not necessarily it is the maximum, but whatever direction I have taken. If I calculate the circulation density through energy calculation divided by the area, or through curl factor also I can calculate. Calculate the curl factor and see the curl direction. If it is not in the same direction what we had calculated as circulation density, then make a dot product. Okay, so this is what it is. We will proceed on this. I believe it is already very difficult session. So the path dependency, magnitude, power of energy, any energy source is either you calculate circulation density along a direction, or you go with the curl factor which already has a direction. Okay, they will come to each other equal to the curl factor through which we calculate the path dependency, or circulation density through which we calculate the path dependency. They will be equal if circulation density is maximum. In that, because the curl direction what we calculate always talk about the maximum. In that direction, if I calculate the circulation density, the energy involved in the closed loop divided by the area, both will be same. Otherwise, both will be different, because curl is always in maximum direction. Whereas if I change the path of the circulation line, then it will change the energy calculation. Okay, so what example we have given this example, then we calculate the circulation density of the earth, that will come as 0, because earth is path independent. Other mind-blowing example we will take in circular situation only. Okay, it will be brainstorming. People can solve it in other way also. We calculate it in a very coarse way, that since they are in same direction, you can just multiply it. Someone can try in Cartesian coordinate system. Someone can try in polar coordinate system, calculating the net energy in a closed loop when the force field is along the displacement direction only, and it has magnitude of twice of the radius. Someone can try through the calculus way, calculating the net energy calculation, that divide it by the area. Okay, so that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.